This is the video for 12.4 ellipses, and so far in this chapter we've looked at parabolas and we've looked at circles, and then we looked at circles kind of from the interior and exterior and also semicircles. So we're going to look at a third figure now, and that's the ellipse. Okay, and just like we did with parabolas and circles, we're going to define it in terms of a description of a set of points, and then we're also going to look at it from an algebraic description in terms of how we can write it with an equation. Okay. So first of all, we're going to define an ellipse in the following way. Let f1 and f2 be any 2 points in a plane, and let d be the constant with d greater than f1, f2. In other words, that distance d is going to be greater than the distance between f1 and f2. Then the ellipse with foci at f1 and f2 and a focal constant d is the set of points P in a plane for which PF1 plus PF2 is equal to D. Okay? So therefore, an ellipse is defined by a focal constant PF1 plus PF2, and if you know the coordinates of F1 and F2 and that focal constant D, you can write an equation for that ellipse. Okay? So we need to know a focal constant, we need to know where the foci points are, and if we know that those things, we can go ahead and write an equation for that ellipse. Excuse me. So let's look at an equation for ellipse and how we can work with that. So it says equations for some ellipses. Okay. Equations for ellipses theorem says that the ellipse with foci at C0, negative C0, and a focal constant of 2a has an equation of x squared over a squared plus y squared over b squared is equal to 1. Okay, a couple things that I want you to notice. When we're doing this, you'll notice that the foci are on the x-axis, C0 and negative C0. And the focal constant is 2a, which is related to a squared here. So whatever that focal constant is, if I take half of it and square it, that will give me that value down here. Okay. Now we also know there's this b squared here, but there's not much mention of it other than this last little bit, which says that b squared is equal to a squared minus c squared. And we know c from our focus points here. So when we're looking at ellipses, everything is about figuring out what is A, B, and C. If you know what A, B, and C are, you can write your equation and you know where the foci points are. Okay? So let's look at standard form of an equation for ellipse in a standard position. Okay, well, when we talk about a standard position for an ellipse, that's an ellipse that's centered at the origin with its foci on an axis. It could be the x-axis or the y-axis. Now, the general that we were working with up here, we had it on the x-axis, but the foci could be on either of those two axes. Okay? The standard form for that equation would be x squared over a squared plus y squared over b squared is equal to 1. So let's take a look at this example problem. It says, given an equation x squared over 49 plus y squared over 64 is equal to 1, describe the following. What are the x-intercepts and the y-intercepts? Well, I know that the x-intercepts, okay, are going to be the place where that ellipse intersects the x-axis. And that's going to be at, since the focal constant is 2a, the x-intercepts and the y-intercepts will be at a and b. Okay? So if this is 49, that means that a squared is 49. Therefore, a is equal to 7. And b squared is equal to 64. Therefore, b is equal to 8. Since b is greater than a here, that means that our ellipse is going to be longer vertically than it is horizontally. Okay? So the x-intercepts are going to be at 7, 0 and negative 7, 0, 0, 8 and 0, negative 8. Okay, so these are the x-intercepts and these are the y-intercepts. Okay. Then it asks us to find the possible x values. Well, since my x-intercepts and my y-intercepts kind of will show the boundary of the ellipse, we can say that the possible x values will always go from negative a to a, and the possible y values will go from negative b to b. Therefore, in terms of the possible x and y values, my possible x values would go from negative 7 to 7, and my possible y values would go from negative 8 to 8. Part C says the symmetries of the graph, if any. So the symmetries of the graph is going to be the x-axis and the y-axis. And when it's centered at 0, 0, the x and y-axis will be symmetry lines for the ellipse. Okay. Okay. From example 1, from the guided example, but from that example and from the example that we just did here on our notes, there's some generalizations that we can pull out of that. First of all, we can pull out that the x-intercepts and the y-intercepts are at a0, negative a0, and 0b, 0, negative b. The possible x and y values are between negative a and between negative b and b. The major axis is the longer axis. So right now, if I look at the picture that I have over here, the major axis is on the x-axis. Now, it doesn't have to be. It could be on the y-axis. And in fact, in the example that we did up here, because my b squared was bigger than my a squared, and because my y values were larger than my x values, I actually had a major axis on that one on the y-axis. Okay? But when we talk about the major axis, it's the longer of the two axes. And the major axis will have a length of either 2a, the distance from negative a to a, or 2b, the distance from negative b to b. And that's all dependent upon which is bigger, a or b. If a is larger, then 2a will be the major axis, and if b is larger, 2b will be the major axis. Whichever one is not the major axis, that one would be the minor axis. So if we find that 2a is the major axis, then 2b would be the minor axis. Okay? The center of our ellipse is at center O here. Okay? At the point 0, 0. And then the foci are either at C0 and negative C0 if a is greater than 0, or we could also say if b is greater than a, then they would be at 0, C and 0, negative C. And that's all dependent upon that major axis. So the foci are always on the major axis. You might want to write that down, that the focus points are always on the major axis. So if you know where the focus points are, you also know which one of your axes is the major axis. And then another term is the idea of a semi-major or a semi-minor axis, and that's just the distance from the center point to one of the intercepts, whether it be from O to A1 or O to A2, or from O to B1 and O to B2. Whichever one is the major axis, then the semi-major axis would be on that same axis. Okay? So that's just some overall generalizations that we can make from the example 1, that guided example in your book. Okay? So next we have the length of the axis of an ellipse theorem, which just says if we have an ellipse of the equation x squared over a squared plus y squared over b squared equals 1, 2a is the length of the horizontal axis and 2b is the length of the vertical axis. We've kind of already talked about it, now we're just writing that as a theorem. So using what we know, let's see if we can do number 2 here as an example. Okay, so it says consider the ellipse that x squared over 8 plus y squared over 16 is equal to 1. Identify the endpoints and the lengths of the major and minor axis. Well, the endpoints would be those x and y intercepts. So if 8 is on the bottom, that means that a squared is equal to 8 and b squared is equal to 16. Therefore, a is equal to the square root of 8, or if we were to simplify that radical, 2 root 2, and b is equal to 4. Now, what that means is that our 4 endpoints are at 2 root 2, comma 0, and negative 2 root 2, comma 0. Okay, those would be the x-axis, the x-intercepts, and then 0, 4, and 0, negative 4. Okay, the major axis, well, B is going to be my major axis. Okay, therefore the major axis will be equal to 2b, or in this case 2 times 4, or 8 units. And the minor axis will be equal to 2a, or 2 times 2 root 2, which is equal to 4 root 2. So that would be the length of the major and minor axis. Okay. Next, we're asked to graph that. So let's take a look at graphing that particular ellipse. To graph it, really all we need to do is get the shape of the ellipse in general, and we can do that using those 4 endpoints. So let's go about doing that. So we've got we have a center at 0, 0. So there's my center point. Now I'm going to plot those points. So my x-intercepts are at 2 root 2, which is so it's just a little bit past 3 here on each side. And then my y-intercepts are at 4 and negative 4, so I'm going to plot those. And now I can go ahead and draw in that elliptical shape. Okay. And that would be a graph of that ellipse. And let's label those points. So this would be at the point 0, 4, 0, negative 4, 2 root 2, comma 0, and negative 2 root 2, comma 0. Okay? So that would be the 4 endpoints there.